Imagine a coffee cup that streams the day's headlines in real time, or a cook's pot that detects the presence of E. coli bacteria before they make you sick, or a TV screen as thin and flexible as a piece of paper. All of these could become a reality if a wonder material called graphene lives up to its hype. It conducts electricity as well as copper does, and conducts heat better than any other known material. At only 1 atom thick, it's also the thinnest known material, and it's stronger than steel. Graphene is made out of plain old carbon, one of the most common and familiar elements out there, so scientists were surprised to find this new form of carbon had such amazing properties. Carbon comes in many crystalline forms called allotropes. The most well-known are diamond and graphite. Allotropes are different forms of the same element with different bonding arrangements between atoms, resulting in structures that have different chemical and physical properties. The way atoms are connected to each other in solid materials has a huge impact on their overall properties. A diamond and a piece of coal are so different that you would never guess that they're both made out of the same element, carbon. In diamond, each carbon atom is connected to 4 other carbons. This is a very strong arrangement that makes diamonds one of the hardest known materials. In graphite, each carbon atom is linked to 3 others in layers of hexagonal shapes that look like chicken wire. The bonds within the hexagonal sheets are strong, but each layer is only weakly attracted to the next, which allows the layers to slip by one another. In 2004, 2 chemists at the University of Manchester in the UK used this property to produce samples of graphene, which helped reveal its remarkable characteristics. They used sticky tape to separate the layers of carbon and graphite. To get an idea of how their technique worked, think of pressing sticky tape onto a piece of graphite and pulling it away, leaving the sticky surface covered with graphite flakes. Then, press the sticky tape to itself and pull it apart. After a few rounds of this, the flakes on the tape would only be a single atom thick, pure graphene. Because graphene is only 1 atom thick, it's considered to be a 2-dimensional material. Despite being the thinnest known material, it's also the strongest material ever tested, 100 times stronger than steel. Let's look at some possible future applications of this amazing material. Graphene is nearly transparent to light. It's also a terrific conductor of electricity. As a result, graphene could be used in combination with other photovoltaic devices to make solar panels that are thin, flexible, and cheap. These light and flexible solar panels could cover the outside of buildings, be molded to fit a car body, or be wrapped around furniture or clothing. This could lead to a new generation of sun-powered, eco-friendly homes and products. Today, most cell phones and tablet PCs have touchscreens. These touchscreens carry an electric charge. When your finger hits a touchscreen, some of the charge is transferred to you, so the charge on the screen decreases. This decrease is measured by sensors located at each corner of the screen, and the information is relayed to a processor, which determines what kind of action to take. Touchscreens made with graphene as their conductive element could be printed on thin plastic instead of glass, so they would be light and flexible, which can make cell phones as thin as a piece of paper. Also, because of graphene's incredible strength, these cell phones would be nearly unbreakable. Many scientists expect that this type of touchscreen will be the first graphene product to appear on the marketplace. Because graphene is thin and flexible, it could be integrated into bionic devices that could be implanted into living tissue. Graphene is very resistant to the salty ionic solutions inside living tissues, so bionic devices made out of graphene could last a long time. Graphene conducts electrical signals, so it could be connected to neurons. Neurons are cells which send weak electrical signals from cell to cell in the body. Imagine lining transistors made of graphene along a damaged spinal cord. These strings of graphene could deliver nerve impulses from the undamaged section of the spinal cord past the damage and onto the nerves and muscles. If this would work, it could allow people to regain use of arms and legs lost to them by spine injuries. These potential applications make graphene a truly exciting material, but there's still a long way to go before any of these products become a reality. A major obstacle is making sheets of graphene large enough and pure enough to be useful. Any non-carbon atoms can disrupt the perfect hexagonal pattern for graphene. Many of the samples produced for research are only a few square millimeters in size. Fortunately, graphene sheets close to 1 meter across have been reported, and breakthroughs seem to come every month. The race is on to be the first to show whether this wonder material can live up to its potential.